Hello everyone. My name is Vikki Kumar Sharma. I'm a maths course instructor, and me along with my friend Jyoti. Today we are going to discuss some of the concepts of set theory. So basically, you are already aware of what set theory is. So today in this presentation, we'll be dealing with some of the operations on set theory using GeoGebra tool. Followed by we'll be doing some two numericals, and we'll see what its applications are. Okay. So as I told you, the first component of our today's presentation will be the visual representation of set operations. So which is usually done in a Venn diagram, and you can see here this page what you see, it's available on the GeoGebra, which everybody has gotten access to. You can even go to that site and do this operation. So I'll just show to you what everything means. So we are aware of the fact that U is a universal set. So what does this includes? So if you see it here, U, so you see it includes set A, B, and C. So it basically includes the element of set A, B, and C, and along with the other elements which might be present apart from the regions of the set A, B, C, which is element 8, as you can see here. Now, similarly, what do we mean by null set? So null set is basically nothing, right? So you don't see any region being colored here. So you might be curious to know, okay, what is the set A then? So you can see here, this represents set A. So you can see here at the bottom, whichever operation will be performing, it will be showing here at the bottom. So now we can see that here A represents this set A, which contains element 1, 2, 3, 4. Similarly,
Null set will have no elements, is it?
null set will have no elements. Okay. Similarly, you can see the next operation. So which is basically set elements of set B will be uh, this, this. So what do we
This is
mean by
C.
A? Yeah, that's the element of C. Now,
Okay.
what do we mean by A complement? So if I highlight that region to you, you can see this. A complement means all those elements except A. You can see all those elements include what? It's basically the elements 5, 6, 7, and 8. Similarly, you can do for B complement and C complement. So similarly, what do we mean by A union B? So A union B means the combination of elements of set A and the combination of elements of set B, and there is no repetitions of elements. So what do we mean by this here? So you can see here. So you can see here set A and set B has been colored here, and you can see only the elements 1, 2, 3, 4, 5, 6 will be the part of A union B. So what do we mean by not repetitions? Not repetitions means this 3 and 4 would have actually, if it was an usual sum problem like A plus B, you would have seen this A plus B, this 3 and 4 element would have been added twice. So that is something ruled out in A union B. So A union B means just the combinations of the elements of set A and set B without repetitions. Similarly, we can see for B union C, as you can see here, Devjyoti,
Okay.
right?
Okay. So B union C has 3, 4, 2, 7, 6, and 5. So
Right,
the elements of B and C without the elements of set A and 8 as well.
right. So similarly, you can see for A union C, right? So it's
Okay. Okay.
understandable from here. So what do we mean by A intersection B then? So just by looking at this figure, can you explain me, Devjyoti, what do we mean by A intersection B?
So A intersection B represents the elements which are in both set A and the set B.
So that's definitely right. So similarly, what do we mean by B intersection C? So we can see here D
4 and
and
6.
C. So it's 4 and 6. Similarly, when we go with the other part, that is A
2 and
intersection C, 2 and 4. So what do we mean by A minus B? So A minus B is this region. So what does it shows basically? Looking at the figure, it means A minus B. So basically set A minus set B. So what will be subtracted from this region? How do you interpret this, Devjyoti? Can you tell me how is this being done? A minus B?
So A minus B should represent the elements which are in set A but not in set B. So all
Right,
the elements like 3 and 4, they are in set B as well. So they will
right,
be eliminated in the set
right.
A minus B.
Nice. So similarly, with the same concept, we can find what is B minus C, what is C minus A, what is B minus A, what is C minus B, and what is A minus C.
C.
Now, coming to the other operations which you can see on the right hand side, it's just the combination of the three sets. Here you would have seen just two sets we were dealing with and one set. But here there is all three sets we are dealing here. So as you could see here, the first here, that is C intersection A minus B. First we will look at what does C intersection A means, right? So C intersection A is something shown here. So C intersection A means this element, and this element minus B means 4 should be gone from here, right, Devjyoti?
Hmm.
So I should get 2 here then. So let's see, what do we get? We get 2.
Yeah.
So similarly, you can see what is C minus A union B. The similar concept we can apply and get this
7.
here. So how is this being done here? I will first take what is A union B. So first let's understand what is our C. So C is all these elements 2, 4, 6, 7. And if we subtract A union B, so A union B means what? This region. So I'll be left with just 7. So as
All
you
the
can,
elements of A and B.
right, all the
In order.
elements of A and B. So you'll be left with just 7. Similarly, if you perform an operation over here, that is C intersection A intersection B complement. So first let's understand what is C intersection A, as we have already done earlier. So we know these elements are the one, that is 2 and 4. So, and it says intersection of B complements. Now B complements means all those regions outside B. So that means the 2 has to be gone out and my only element left will be 4. Right, Devjyoti?
Hmm.
So let's check that. So this is not the case.
Oh.
Then
Okay,
what
so only
happened
2
here?
will remain.
So how is that happening? Can you give me the explanation for this?
2 and 4, which are common in A and C. And then 4 is actually in the set B, which is not in A intersection C. So basically what will happen is that 4 will be eliminated from this set.
Okay.
Okay, so 2 will be remaining because it is not in the set B. It is in the set B complement.
So here you can see another operations. So again here it says that is B intersection C intersection A complements. So that is just an element 6 here, as you could see.
Yeah,
So
yeah.
what does this means then? Now B intersection C. Now B intersection C, if I have to show you here, so this is going to be 4 and 6. And intersection of now this B intersection C intersection A complements. Now what is my A complement? Now A complement will be this part,
Yes, yes.
right? So this is going to be this part. So finally, then I'll be left with. So when I take those two operations, so basically A complement and B intersection C, I'll be left with just 6. Similarly, the rest other operations can be understood in a similar manner. So I'll just show you how does those operations and which elements actually it covers here. So you can see this, and this.
So
All right.
A union B complement. So is that the same as A complement union B complement?
Okay, so shall we understand that? So
Yeah,
let's take
sure.
first. So A union B means this region. So except this region, what will I have other elements? So I'll have 7 and 8 when I'm taking A union
B
A
whole complement.
union B complement. So I'll just have elements 7 and 8. Right?
Yeah.
Now next you are saying what is my A complement union B complement. So what is my A complement first? A complement is my elements
Okay.
5, 6, 7 and
7,
8.
8.
And what is my B complement? And my B complement
1
is
to 7, 8.
1, 2, 7, 8. So now you are telling it's a union of them, right? So what you will be left then, which all elements you will have? So you will have 1, 2, 5, 6, 7, 8, right? So this is something I could not show here on this diagram. So this is something which you can practice by your own. Okay. So Devjyoti, as we have already gone through some of the set operations, so I have a small assignment for you here. So here you can see on the left hand side, there is a table which represents a set notation, visual presentation and word descriptions. And on the right hand side, you see there are Venn diagrams and the word descriptions of this. So all we have to do here is match this visual representation and word descriptions from here. So Devjyoti, can you tell me which of these Venn diagram represents A intersection B?
I think the top right one.
This one,
A
is it?
and yeah, A intersection B.
Okay. And what is the word description for this?
Yeah, A and B.
A and B. Okay. Nice. Okay. So what about A intersection B complement?
So A will be there
Hmm.
and B will not be there.
Okay.
Which part? I think the first one.
This one, is it?
Yeah, B
Okay.
is
You're right.
there, but B is not there. Okay.
Okay.
So A
Next, what
but
is
not B. That is the
A but not B? Okay. So what about the third one? Just the opposite
yeah.
one.
So that is the opposite one.
Okay.
B but not A.
Okay. B but not A. What about this last one? So of course, this will fit in here.
This is the visual
But what
representation.
is the word
So
description for this?
yeah, so this is the not A and not B.
All right. Thanks, Jyoti.
Yeah, sure.
Okay, so let's do with the second part of the presentation wherein we told like we'll be doing with two numericals. So there are two popular numericals you see in the set theory. One is the word description of a problem and then followed by you make the Venn diagram and then you solve it. Similarly, you will have another type of a problem which will have set comprehensions and you are expected to list out those sets, the elements of sets, and then do the operations. So once you know your sets, then you can perform an operation. That is your second question. So let's deal with the first question. So in the first question, it says in a school, out of 350 students, 300 students have opted for at least one subject, that is English, physics, mathematics, and if 140 students opted for English, 196 students opted for maths, and 136 students opted for physics, and 28 opted for all three subjects, then then you are expected to find out the number of students who opted for exactly two subjects. Okay, so how is this done? So basically, one way of doing is to do the diagram of this Venn diagram. So here in the question it says your E is 142, right? Your E is nothing but English. For English, there are 142 students. For physics, there are 136 students. And for mathematics, there are 196 students. And here we can have our universal set U, right? So now we have, since we have to find out the number of students who opted for exactly two subjects. So that means we have to find out this region, that is A, B, and C. So this is something I have highlighted it earlier. So you can see the one which is marked, I mean, just scratched around with the black sketch. You can see those are the reasons which we have to find out. Now, in order to do so, first we have to know what is our E union P union M. So as in this question, it says we are just dealing with 300 students who opt for these subjects. So that is nothing but 300. And our universal set is 350, right? And so now you can see here, Devjyoti, it's so basically what will be our E union P union M? It's going to be the sum of all these regions, right? Which is represented
Okay.
here, right?
Okay.
Okay, so that is something done here. So you can see this part which represents E only, this part which represents P only, and this part which represents M only. And what you see here is 28 is common for all, so that is something listed here. And A plus B plus C, this A, B, C, that represents just E, P, but not M. Similarly, C represents only P and M, but not E. Similarly, your B represents only elements which is in E and M, but not in P, right?
Yeah.
So now when we simplify this, so this is like very standard form, we have written it. All you have to do is just simplify this, and then you will find out that A plus B plus C is equals to 118. Okay, so now here we have a problem to us. So this is our second question, which involves three sets, that is S1, S2, and S3, and it is given in set comprehension form. And we are expected to give these answers, which is asked here. Answer the following. So whenever you have a set comprehension, the easiest way of solving these kind of problem is to list the elements when asked, right? So here in the question it says S1 is set of elements of x such that x is a real number, and it also has to make sure that x square plus 16 is equals to 0. Now it says that this has to be equal to 0. So now we know that x square plus 16 is equals to 0. And if I have to solve this equation, so I get x square is equals to minus 16. So when I solve this, you see we get what? A complex root, right? So this is going to be negative of 16. So you don't have any real root. So you don't have basically r. It's a complex root, right?
Okay. Okay.
So, but in the set S1, what does S1 says? You need to have only elements or real elements. So you don't have any elements as such in this, right? So this is going to be an empty set, right?
No
So,
element.
so there is no element in this. So S1 is empty. Okay. Similarly, if I have to list that other thing, S2, so you can see here, it's again says x belongs to a real number such that x minus 4 times x minus 3 is equals to 0. Now I have to solve this equation. So for it to be 0, x should be either 4 or 3, right? So if, and you see this x 3 and 4 are a real numbers, right?
Okay.
So my S2 will be 3 comma 4, right?
Yes.
Similarly, if I have to solve for S3, so what does it says? Now x is a natural number, it's not a real number, so we have to pay attention to that. And look at this part. So this is going to be x square minus 16 times x square minus 9 equals to 0. So if I have to solve this individually, how can we write this? So we can write this as so this can be written as x plus 4 times x minus 4, and this can be written as x, basically this can be written as x plus 3 times x minus 3 is equals to 0. So this is from our standard formula what we have learned in our elementary school. A square minus b square is nothing but a minus b times a plus b, right? So that is how we got this. So from here, if we have to find out what is our x value, so if you equate all these to 0, so you get x equals to minus 4 minus 3. What are the other elements, Devjyoti?
Plus 4 plus 3.
So plus 4 plus 3, right? So I can write them here. So this is something we get. So basically our S2 should contain, I mean, these are the x values which we got, but in the question it says what? X is a natural number. So can you tell me what will be the elements of S3, Devjyoti?
3, 4, and can you just remind me what is the definition of natural number?
So natural numbers are a numbers from 0 to infinity, and it's an integer value. So you'll have an integer values from 0, 1, 2, 3, 4, 5, 6, 7 up to infinity.
Okay.
So those are the numbers.
Okay, so only 3 and 4 will be there. Minus 3, minus 4 will not be there.
Exactly. Okay. So now in the question they're asking, what is the cardinality of, look at this question. What is the cardinality of S1 union, S2 union, S3? So could you tell me, Devjyoti, what is S1 union, S2 union, S3?
S1 will not have any element.
Okay.
S2 will have 3 and 4. S3 also 3 and 4. So total elements will be 3 and 4.
So should I write this again, 3 and 4?
No.
Why?
No, because
Why
because a set does not contain duplicate elements.
Very good. So I just have 3 comma 4 here. So what is the cardinality then?
2. Cardinality
will be
2.
2. Okay, so you see for this the answer is 2. Now what is the cardinality of S1 intersection S2 intersection S3? So can you tell me with that, Devjyoti? What is S1 intersection S2 intersection S3?
Now S1 does not have any element in it. Although S2 has 2 elements, but there is no element common between S1 and S2 or S1 and S3. Although there are 2 common elements between S2 and S3, but as S1 has no element, so cardinality will be 0, and there will be no element inside this S1 intersection S2 intersection S3.
Okay, so but if it was just to ask you what is cardinality, what is S2 intersection S3, then what will be the answer?
So S2 intersection S3 will have 2 elements, 3 and 4, as both
Okay.
are common in these two sets.
Okay, so this will be 3 comma 4. But the
Yeah.
moment you take this empty set as well, so you
Ah,
get what?
0.
So
I mean,
0.
cardinality 0.
Yes. So for this, the cardinality will be
0.
so basically there is no element, so
Ah,
cardinality will be, so answer for this is 0. Now what is S1 minus S2, Devjyoti? Can you tell me?
yeah, so S1 minus S2 are the elements which are there in S1 but not in S2, right?
Yes.
So there are no elements in S1, so it will be also 0.
So the cardinality for this is again 0.
Yeah.
Okay. Now the next question is S2 equals to S3?
So the elements are all equal, so the set
Okay.
should be equal.
Okay. So this is, yes, this is right, isn't it? So
Yeah.
Devjyoti, if we had some set like this, let's say a hypothetical set S2, which has an elements, let's say like 3 comma 4 comma 5, and I have S3, my set, which has element 3 comma 4, or let me say this is S5 and this has S4, S6. So is S5 equals to S6?
No, S5 is not equals to S6.
Why?
For two sets to be equal, I mean all the elements in the set should be equal. I mean two should be same in between
Okay.
those two sets.
Okay,
Right. So
nice.
S5 has the element 5, which is
Hmm.
not there in S6. So
Right.
S5 is actually I mean S6 is a subset of S5.
So if I have to write this as S6 is a subset of S5, so is this
S5.
an answer?
Yeah, we can see that.
So this is all for from my side. So I think Devjyoti would like to show some application part of this set theory. So Devjyoti, could you please go ahead with that?
Yeah, sure. So basically, guys, this part which I'm going to show, that is strictly out of syllabus, and there will be no question coming from it. And this is based on Python. So we would like to show you 2-3 lines of code which tells how to implement this set theory in Python as well. But as Python is not taught in the course yet, and you have not studied also, so there will be, as I told, no question from here. Okay, this is just for entertainment and for further reading fun purpose. So we are, what, I'll just show my screen once. So I think the screen is visible. uh, so this is, we will be using the software called application called Anaconda. You can download it from this website. It is an open source software basically. So with Anaconda, when you download the Anaconda package, there is a thing which comes up called Jupyter Notebook. So this is how the Jupyter Notebook looks like, and we are using Python 3 here. So you can, so we have wrote some program previously. Like for example, you can say, as we have shown, that a set contains elements written inside curly braces. So 3, 1, 2, again 3, 5, 4, 5, 6, 8, etc., etc. So the as we know that the set elements are unique, so duplicate elements will not be allowed. Another set is also written 1, 2, 6, 7, 8, 9, 9, 10. 9 is repeated twice. 10, 7, 10, etc. 10 is also repeated. So now if we print A and B, these two sets, then it actually gives us all the elements 1, 2, 6, 7, 8, 9, 10. So the numbers which are repeated, they are not taken twice, but only once. Now a set also can contain any type of elements, as we have seen. So like as you can see, I mean, there are 3 names connected here, written here: Dhoni, Saurabh, and Sachin. And we can combine these two sets. So like the first set A and this third set C, we can make an union of these two sets. And if we run them, then we can see that Sachin, Saurabh, Dhoni, this is another, this is a combination union of these two sets. one other thing which we should remember is, although this time it is not shown here, is that there is no order in writing elements of the set. Okay, so when I ran this program for the first time, it was showing 1, 2, 3, 4, 5, 6, Sachin, comma 8, comma Saurabh, like that. Okay, comma Dhoni. So you should remember that there is no order in the set theory elements. Similarly, we can do intersection also, the AND operator, right? So A intersection B or B intersection A, any kind of operation can be done, and you can print that by the same way. And so you can see, if we do an intersection of B, the set B, this set, actually this set B and the set A, so we can see what are the common elements, right? So 1 is a common element, 2 is a common element, then 8 is a common element in both sets, and 6 is also a common element. So those will be required, and those can be written. Then we can check in Python whether one set is a subset of another set. So we can check whether the first set x1 is a subset of x2. So x1 contains 1, 2, 3, 4, 5, 6. x2 contains 3, 5, and 6 only. So basically, as we know, 3, 5, 6, this x2 will actually be a subset of this first set. Okay, so if we check whether x1 is a subset of x2 or x2 is a subset of x1, we can check that x1 is not a subset of x2. This is a false statement that x1 is a subset, but x2 is actually a subset of x1. Okay, which is a true statement. And as one is a subset of other, so basically the other set is the superset. We can check that also, that one set is a x1 is a superset of x2, but x2 is not a superset of x1. So that's how you can implement the set theory in Python programming.
Nice.
So yeah, that is from my part.
So I hope you like this video. Thank you, everyone.